Good morning, students. Today we are starting a new chapter and the last chapter of chemistry, chapter number 5, periodic classification of elements. Students, around the year 1800, only 30 elements were known, and all these had seemingly different properties. But by the year 1865, the number of elements known went up to 63. And at present as many as 118 elements are known. So as more and more elements were being discovered, scientists gathered more and more information about their properties. So it became difficult to study and remember the properties of each element. And to overcome this problem, scientists started looking for some pattern in their properties on the basis of which they can classify all the known elements to make their study easier. And this necessity led to the classification of elements. The earliest attempt to classify elements was actually the grouping the elements into metal and non-metals. But the defect in this classification was that it had no place for metalloids. Metalloids means the elements which have properties of both metal and non-metals. Then later on in 1808, J. Dalton proposed his atomic theory, and according to this theory, atoms of one element can be distinguished from the other one on the basis of their atomic masses. Therefore, all the earlier attempts at the classification of elements were based upon their atomic masses. So basically in this chapter we will discuss about all the theories about the classification of elements. So first we are starting with the Dobernier's triads. Students, in 1817, J. W. Dobernier, a German chemist, tried to arrange the elements with similar properties into groups. These group of 3 elements having similar properties were called Dobernier's triads after his name. He further observed that when 3 elements of any particular triad were arranged in order of their increasing atomic masses, the atomic mass of the middle element was roughly the mean or average of the atomic masses of the other 2 elements. Let's see the example. I'll explain you with the help of these examples. Let's see the first triad. The 3 elements lithium, sodium and potassium having similar properties because they all react with water to form alkalis. Correct? And now you just look at the masses, atomic masses of these 3 elements. When we take out the average or mean of the masses or atomic masses of the first and the third element, we will get the product which is nearly or roughly equal to the atomic masses of the middle element. For example, atomic mass of lithium is 7 and the atomic mass of potassium is 39. And the average of these 2 is 23, which is exactly equal to the atomic mass of sodium. Likewise, one more example is there. The next triad of Dobernier's, calcium, strontium and barium. Atomic mass of calcium is 40 and the barium is 137. And the mean of these 2 is 88.5, which is nearly or roughly equal to the atomic mass of strontium. So like this he prepared 3 triads. First one with the 3 elements lithium, sodium, potassium. Second triad is a group of 3 elements calcium, strontium and barium. And the third group was chlorine, bromine and iodine. So this was the exactly written or said by the Doberniers. But here also other scientists noticed some limitations. Actually, Doberniers could identify only 4 triads from the elements known at that time. In other words, all the elements known at the time could not be arranged as Dobernier's triads. For example, the other 3 elements, nitrogen, phosphorus and arsenic, these 3 have similar properties, right? Therefore, they can be also regarded to form a triad. But however, the actual atomic mass of the middle element, which is phosphorus, is much lower than the average of other 2. So this was exactly the limitation of the Doberniers. Student, next theory was given by Newland. Actually, the idea of Dobernier's triads encouraged other chemists to search other trends between the properties of elements and their atomic masses. Then in 1866, John Alexander Newland arranged then known elements in order of increasing atomic masses. Actually, he started with the hydrogen, the elements having the lowest atomic mass. He found that the properties of 8th elements were similar to the properties of the first element. Actually, he compared this with the octaves found in musical scale. Therefore, he called it as Newland's law of octave. So, exactly what is the Newland's law of octaves? That when elements are arranged in the order of increasing atomic mass, the properties of 8th element are a repetition of the properties of the first element. Now look at this series. Now if we start with the lithium as the first element, then the 8th element from it will be sodium, correct? So according to Newland's law of octave, these 2 elements must have similar properties. It has actually been found that lithium and sodium have similar properties. Again, if we take sodium as the first element, then 8th element from it will be potassium, right? Now according to Newland's law of octave, these 2 elements must have similar properties. This has actually been found to be so. In fact, all 3 elements, lithium, sodium and potassium, have similar properties. So this is the actual law of Newland's, which was called Newland's law of octaves. But in this theory, some limitations were there. The first limitations of Newland's law of octave was, Newland's law of octave was actually applicable only up to calcium, as after calcium every 8th element did not possess properties similar to that of the first. Second was, Newland assumed actually that only 56 elements existed in nature, but several new elements were discovered whose properties did not fit into the law of octaves. And the next was, in order to fit elements into his table, Newland adjusted 2 elements in the same slot, but also put some unlike elements under the same note. So these were the limitations of Newland's law of octaves.